Hi, dear students, I'm Dr. Kumar, Associate Professor, Department of Mathematics, Sai Vidya Institute of Technology, Bangalore. So in this video, I'll be discussing about how to show that the given vector is solenoidal and irrotational. So I'll start with the definition of a solenoidal vector. So a vector f1i plus f2j plus f3k. So this is a vector here. Is said to be solenoidal if the divergence of that vector is zero. So div f or del dot f is zero. And the same vector f is said to be irrotational, then the curl of that vector field is equal to zero. So, and remember, irrotational vector can also be called as conservative force. So these are the two important concepts in our vectors. So divergence is zero means it is called solenoidal vector, and curl of a vector is zero means it is called as irrotational vector. So for certain examples, we will see how to show that the vector is solenoidal and irrotational, etc. So I'll start with the first example. Show that vector f is equal to, so y square minus z square plus 3yz minus 2xy plus 3xz plus 2xy j plus 3xy minus 2xz plus 2z is equal into k is both solenoidal and irrotational. So for this vector, I'll verify first whether divergence is zero to say that it is solenoidal, and then I'll find out what is the curl of this vector, and if it is zero, I will conclude that it is irrotational or conservative force field. So let us see how to find div and curl to check solenoidal and irrotational nature of this. So first, given vector f equals, it is y square minus z square plus 3yz minus 2x into high plus 3xz plus 2xy into j plus this is 3xy minus 2xz plus 2z into k. So this is the given vector here. So first I'll calculate the divergence of this one. So divergence of this vector. So we know that div of, so div of a vector, divergence of vector is given by the formula. It is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So where this f1, f2, f3 are the components of I, j and k. So f1 stands for the coefficient of I, f2 the j term, and f3 is the k term. So according to this formula, you have to differentiate f1 with respect to x partially. So I mean this term you have to differentiate partially with respect to x. So this is equal to, so this term if I differentiate this with respect to x means y and z are constant here. It is a partial differentiation. So differentiation of this term, it becomes zero. And even this term also becomes zero, free from x. Even this term also becomes zero. And here we get minus 2 into differentiation of x is 1. So dou f1 by dou x is just minus 2, minus 2. Next, dou f2 by dou y means, I'll just write here, this is f1, this is f2, this is f3. Now, f2 means this we have to differentiate with respect to y. So with respect to y means it is 2 with respect, there is no y here, so it is 0. Here differentiation of y is 1, so it is 2x. It is plus 2x. And the last dou f3 by dou z, this with respect to z we have to differentiate. If I differentiate this with respect to z, this is z, sorry, z with respect to z. So this here there is no z term, so it is 0. Here differentiation of z is 1, so it is minus 2x, and the last term differentiation of 2z is plus 2. So here if you observe, all these terms gets cancelled, so we get div f equals 0. So this shows that vector f is solenoidal. Vector f is solenoidal. This is how we can show that the given vector is solenoidal. Now, in the same way, we can prove that the vector is irrotational. Now, to show To show that it is irrotational, so let us find the curl of this. So we know that the curl of a vector, I can say it is del cross F. So the formula is this. It is determinant of I cap j k. This is dou by dou x, dou by dou y, dou by dou z. Here f1, f2, f3. So this is the formula for the curl of a vector, as we know. So now let us substitute our f1, f2, f3 from this vector in this determinant. So this is equal to determinant of I cap dou by dou x. I'll write f1 here. And you know f1 is, it is y square minus z square plus 3yz minus 2x. Next term was j cap. This is dou by dou y of f2. f2 is, it is 3xz plus 2xy. The last term was k cap, dou by dou z of f3. f3 is, it is 3xy minus 2xz plus 2z. So the values of f1, f2, f3 are substituted in this determinant. Let us expand. So this is equal to I cap into, so I cap into, so this one, leave this column, leave this row. It is cross product of these two, dou by dou y of this minus dou by dou z of this. So it is dou by dou y of, this is 3xy minus 2xz plus 2z minus, it is dou by dou z of this. It is dou by dou z of, it is 3xz plus 2xy. So this is the item, then minus j term now, j cap into. So leave this column, leave this row with this one and this. So this cross product of these two. It is dou by dou x of, the last one. It is 3xy minus 2xz plus 2z, then minus, it is dou by dou z of, it is y square minus z square plus 3yz minus 2x. So this is the j term and plus k term. So k cap into this is leave this column, leave this row. It is a cross product of these two, dou by dou x of this in minus dou by dou y of this. It is dou by dou x of, it is 3xz plus 2xy minus, it is dou by dou y of y square minus z square plus 3yz minus 2x. Right? So just the determinant was expanded. Now, if you find the partial derivatives of these things and simplify, you will going to get what is the curl F. So let us calculate the curl F now. So this implies curl F equals, so sorry, curl, I go to the next page. Curl F equals, the first term, it is I cap into, let us differentiate this partially with respect to y, means it is 3x and these two terms are 0. It is 3x minus this with respect to z means 3x into z is 1 and this term is 0. So I get 3x minus 3x. So the first term was, it is 3x minus 3x minus j cap into the second term. So differentiate this partially with respect to x now. First term, x means it is 3y minus 2z will come here. 3y minus 2z. It is 3y minus 2z. And next term, this with respect to z means differentiation of z square is minus 2z. Minus into this minus, it becomes plus 2z. So it is plus 2z. And the last term, this with respect to z means it is 3y into z is 1. So it is minus 3y. This is the j term plus k hat into the k term. So if I differentiate the first term with respect to is dou by dou x of this. So it is 3z. Here x is 1, 2y, 3z plus 2y. 3z plus 2y. Then minus this term with respect to y means differentiation of y square is 2y. 2y with minus, it is minus 2y. and here you get plus 3z, 3z with minus 3z. So it is minus 2y minus 3z. This is the k term. And now if you observe all these things, every term gets cancelled here. So the resultant value is 0. So this implies curl f is equal to 0. So this shows that, this implies that the vector f is irrotational, or I can say this as conservative force field. So this is how we can show that the vector is solenoidal and irrotational by finding a divergence and curl here. And this is a common question. Whenever we ask, show that the vector is solenoidal, we have to calculate what is divergence. And whenever we ask, show that it is irrotation, find curl. If the answers are 0, you can just say that the vector is solenoidal, irrotational, and etc. here. In the same way, you can try this problem later. So show that vector f is equal to, it is xi cap plus yj cap divided by x square plus y square is both solenoidal and irrotational. So like a last problem, you can find what is divergence of this and what is the curl of this vector, and both are 0 means you can show that it is solenoidal and irrotation. This is how we can find this is how we can verify the vectors is solenoidal and irrotational for a given problem. Thank you.